Now we talk about multiplexer. In digital system, many times it is necessary to select single data line from several data input lines, and the data from the selected lines should be available on the output. The digital circuit which does this task is called as a multiplexer. It is a digital switch. It allows digital information from the several sources to be routed on the single output line. This is shown in the figure. This basic multiplexer has several data input lines and a single output line. The selection of the particular input line is controlled by a set of selection lines. Since multiplexer selects one of the input and routes into the output, it is known as the data selector. Normally, there are 2 power n input lines and n output lines whose bit combinations determine which input is selected. Therefore, multiplexer is many into one, and it is provide the digital equivalent of the analog selector switch. 2:1 multiplexer. The figure shows 2:1 multiplexer. I naught is applied as an input to one AND gate, and I1 is applied to an input to another AND gate. Enable input is applied to the both gates as a one input. Selection line A is connected to second input to the second AND gate, and inverted Z is applied to the second input to first AND gate. Output of the AND gates are applied as a input to OR gate. Working of 2:1 multiplexer. When E equal to 0, output is 0, that is Y equal to 0, irrespectively of any input condition. When E equal to 1, the circuit works as follows. When A equal to 0, the inverted A, that is 1, gets applied a second input to the first AND gate. Since A is applied directly as an input to second AND gate, it is output goes 0 irrespectively of the first input. Since the second input of the first AND gate is 1, it is output is equal to the first input, that is a I naught, that is I naught. Hence Z equal to I naught. Exactly opposite in the case of when A equal to 1. In this case, second AND gate output is equal to its first input I1, and first AND gate output is 0. Hence Z equal to I1. Both these cases are summarized in the table. Next, we talk about 8:1 multiplexers. The figure shows 8:1 multiplexer. There are 8 input lines, 1 output line, and 3 selector lines as shown in the function table, and selection of particular input lines is controlled by 3 selection lines. Now we talk about 4:1 multiplexer. The figure shows 4:1 line multiplexer. Each of 4 lines I0 to I3 is applied to the one input of an AND gate. Selection lines are decoded to select particular AND gates. For example, when A B equal to 0 1, then the AND gate associated with the data input I1 has two of the inputs equal to 1 and the third input connected to I1. The other three AND gates have at least one input equal to 0, which makes there is the output equal to 0. The OR gate output is now equal to the value of I1. These we can say data bit I1 is routed to the output when A B equal to 0 1.